Very warm greetings of the day to each one of you, ladies and gentlemen. Aviation Safety India is happy to share a video presentation on 6th generation crew resource management, that is threat and error management. During this video presentation, we would be covering threats, errors, and undesired aircraft oblique helicopter states and how to manage them in safe and efficient manner. I'm sure that you'll find the video interesting and educative. So here we go. Threats and errors are an integral part of aviation operations and they have the potential to generate undesired aircraft states. Threat and error management is integral to all safety processes and provides defenses against hazards in operational situations. It involves identifying hazards to safety, that is threats, errors, or undesired states oblique deviations. The concept of threat and error management is to complete the mission in a safe and efficient manner. The mission may be to conduct a flight, aircraft maintenance, or preparing an ops manual and SOPs, etc. Thus, it can be seen that threat and error management can be applied to all aviation activities of an organization. Now we shall discuss components of threat and error model. There are three basic components in the threat and error management model. First one is threats, errors, and undesired aircraft states. First, we shall discuss threats. Threats can be defined as a situation or event that has the potential to compromise safety. Threats have the potential to adversely affect flight operations by reducing margins of safety. Some anticipated threats. Some threats can be anticipated since they are expected or known to the flight crew. For example, flight crews can anticipate the consequences of a thunderstorm by planning their response in advance or prepare for a congested airport by making sure they keep a good lookout for other traffic. Unanticipated threats. Some threats can occur unexpectedly, such as an in-flight aircraft malfunction that happens suddenly and without warning. Weather conditions may turn out to be different from the forecast. Latent threats. There are some threats which may not be directly obvious to or observable by the flight crews and may need to be uncovered by safety analysis. These are considered latent threats. Examples of latent threats include equipment design issues, illusions, or shortened turnaround schedules, etc. Now we shall have a look at some of the pilot-related threats. First one is lack of experience, skill, knowledge, and situational awareness. Lack of recency and proficiency. Attitude, fatigue, stress, or confidence, complacency, poor decision making, congested traffic environments, equipment malfunction, remote and marginal runways, advanced landing grounds and helipads, weight and balance related issues. Now look at the ATC related threats. Lack of skill, knowledge, experience and competence of ATC controllers. Communication failure, misinterpretation and misunderstanding. Coordination, traffic congestion, adverse weather, distraction and loss of situational awareness, airport layout, airspace design, and navigation aids. Now we shall discuss some maintenance related threats. Lack of experience, knowledge, skill, and competence of maintenance personnel. Non-adherence to SOPs, checklists, and instructions, etc. Poor maintenance of equipment, improper tool control, poor working environment, lack of effective supervision, poor documentation, fatigue, stress and pressures, attitudinal deficiencies, lack of communication, mutual understanding, and interpersonal relations between flight crew and maintenance personnel. Now we shall discuss threat management. Regardless of the types of threats, the effectiveness of the flight crew's ability to respond to the threats will depend on the detection of the threats with due anticipation so that they can take appropriate measures to manage the threats. Now, we'll discuss some of the threats and how to manage them. First threat, lack of knowledge, skill, and awareness on the part of aviation personnel. Now, to manage this threat, operators are to ensure result-oriented training by competent instructors on regular basis, and operators should monitor the assimilation levels of individuals. Next threat is non-compliance with SOPs, checklists. How to manage this threat? Encourage, motivate, and enforce compliance. Zero tolerance for non-compliance. Next threat, poor situational awareness. How do we manage the threat? It is essential to educate the pilots and other personnel about the importance of situational awareness, the need for proper planning, preparation, briefing, knowledge about aircraft/helicopter, their systems, limitations, emergencies, environment, and flight-related knowledge, etc. Next threat is adverse weather conditions. Then how do you manage this threat? Ensure proper weather briefing, analysis of weather, knowledge about the thunder, hail, /dust storms, lightning, wind shear, icing, fog, use of weather radar, the techniques of weather avoidance, weather-related threats during various seasons, regions, spatial disorientation, illusion, controlled flight into terrain, etc. Pilots must avoid flying in adverse weather conditions, and they should not hesitate to divert or return if unable to continue flight due bad weather. The pilots must have the courage of conviction to say no if the safety of the flight is likely to be compromised, and they should not succumb to pressures. Now we shall discuss errors. Errors can be defined as actions or inactions which can lead to a deviation. As humans, we are fallible and errors are to be expected. Even the most experienced and well-trained person can make an error. Errors can be spontaneous, that is, without direct linkage to specific or obvious threats, linked to threats, or part of an aviation error chain. Examples of errors would include the inability to maintain stabilized approach parameters, executing a wrong automation mode, failing to give a required callout, or misinterpreting an ATC clearance, etc. Regardless of the type of error, an error's effect on safety depends on whether the flight crew detects and responds to the error before it leads to an undesired aircraft state and to a potential unsafe outcome. This is why one of the objectives of threat and error management is to understand error management, that is, detection and response, rather than solely focusing on error causation and commission. Operational errors that are timely detected and promptly managed do not lead to undesired aircraft states and as such become operationally inconsequential. Capturing how errors are managed is as important, if not more, than capturing the prevalence of different types of error. Some errors are quickly detected and resolved, thus becoming operationally inconsequential, while others go undetected or are mismanaged. A mismanaged error is an error that is linked to or induces an additional error or undesired aircraft state. Now we shall discuss types of errors. Flight handling errors, for example, unintentional speed or altitude deviation. Procedural errors, for example, performing checklist items from memory, thus missing out on some important points. Communication related errors, for example, missing, misinterpreting, or misunderstanding ATC and other communications. Now we shall talk about typical errors. Inaccurate planning or scheduling, non-standard communication or handovers, mishandling the aircraft/equipment, incorrect system operation or management, that is selecting the wrong switch, procedure or checklist related errors. Now we shall talk about error management. Error management refers to the process of correcting an error before it becomes consequential to safety. It is to be kept in mind that an error is the mistake made when threats are mismanaged. It is possible for error to occur without an observed threat. Error management has two aspects. First, if we realize that we have made an error, we need to correct it before it leads to an unwanted consequence. Please remember that in error management, we are trying to manage the impact of the past. When error occurs, Resist and resolve filters help us to prevent the error from having unsafe consequences and to avoid making the same mistake in the future. And now in resist, the hardware is tangible tools and software is the intangible tools that exist before the human enters the situation. Resolve, resolve are the actions that humans take to resolve the error before it leads to an unwanted consequence. Please note that errors that have no immediate effect on safety can be the most insidious of errors. Since these errors do not have an immediate negative outcome, individuals will start to believe that making these errors that are not following procedures is low risk. Therefore, over time, these errors can lead to the normalization of deviation from procedures, that is, bad norms. Now we shall discuss undesired aircraft states. Threats and errors not detected and not managed correctly can lead to an undesired aircraft state. Undesired aircraft states are generally defined as an unintended situation resulting in a reduction in safety margins. They are usually transient in nature, only existing for a limited time until the state is either recovered or leads to an incident or accident. Now we shall have a look at pilot-related undesired states. Aircraft unstable on approach due to a failure to observe the wind direction. Aircraft enters an unusual attitude after an evasive maneuver to avoid an in-flight collision. Aircraft running low on fuel due to skirting around adverse weather which was not catered for during pre-flight planning. Cabin crew related undesired states, uncontained fire in passenger seat due to the personal electronic device. Passengers evacuate the aircraft when unsafe to do so. Inflatable slide deploys on the stand due to the door not being disarmed before opening. ATC related undesired states, aircraft entering the runway when it should not, and aircraft vacate the runway at the position where it should not. Aircraft climbing, descending to another flight level, oblique altitude than it should, and aircraft not climbing or descending to the flight level, oblique altitude where it should. Maintenance related undesired states, the incorrect screws installed in a windscreen leading to the windscreen departing the aircraft during flight. A tool is left in the engine inlet which is ingested leading to an engine failure on takeoff and a forced landing. Adequate torque not given to nuts and bolts resulting in mishaps. Engine or other panels flying off in the air since they were not properly secured. Now we shall be discussing threat and error management. How well threats and errors are managed is determined by the individual's ability to detect them in time. If threats and errors go undetected, they can lead to undesired states, and if left unmanaged, can lead to an accident or incident. If we can recognize the threats, then we can come up with strategies to manage the threats so that they don't contribute to errors. However, if we don't recognize the threats or if we do not manage the threats correctly, then errors can occur. If an error occurs, there may be defenses already built into the system. For example, inspections or operational checks that resist the error so that there is no harmful outcome. An important learning and training point for flight crews is the timely switching from error management to undesired aircraft state management. For example, a flight crew selects the wrong approach in the flight management system. The flight crew subsequently identifies the error during a cross check prior to the final approach fix. However, instead of using a basic mode or manually flying the desired track, both flight crews become involved in attempting to reprogram the correct approach prior to reaching the final approach fix. As a result, the aircraft descends late and goes into an unstable approach. This would be an example of the flight crew getting locked in to error management rather than switching to undesired aircraft state management. Also, from learning and training perspective, it is important to establish a clear differentiation between undesired aircraft states and outcomes. Undesired aircraft states are transitional states between a normal operational state, that is a stabilized approach, and an outcome. Outcomes, on the other hand, are end states, most notably reported safety occurrences. An example would be a stabilized approach, that is a normal operational state, that turns into an unstabilized approach, that is an undesired aircraft state, that results in a runway excursion, that is the outcome. The training and remedial implications of this differentiation are of significance. While at the undesired aircraft state stage, the flight crew has the possibility through appropriate threat and error management of recovering the situation, returning to a normal operational state, thus restoring margins of safety. Errors/deviations require immediate action before negative consequences occur. Once the undesired aircraft state becomes an outcome, recovery of the situation, return to a normal operational state, and restoration of margins of safety is not possible. It must be understood that the better the communication, the fewer will be the errors. Hence, emphasis must be laid on better communication during aviation operations, using correct aviation terminologies to avoid misinterpretation or misunderstanding. Flight and maintenance crew should always follow SOP and checklist. Remember that the flight and maintenance crews who fail to follow SOPs are twice as likely to commit errors. Flight crews must properly assess the situation, develop strategies, and make informed decisions. Internal and external safety audits are critical to safety and health. It should be known that aviation professionals are human and therefore prone to error. Acceptance of vulnerability is the first step in taking responsibility and avoiding risk-taking behaviors. Detecting, reducing, and containing human errors are the most effective ways of improving safety. Please remember that safety is an attitude, both on and off the job. Safety can be proactively managed, that is, all accidents and incidents can be prevented. All operating exposures should be safeguarded and barriers should be erected and maximized. Safety comes from proper decision making, usually a product of good crew resource management. Safety should be continually recognized and reinforced. It must be very clear that both the management and employees are responsible for avoiding accidents and incidents. Now we shall have a look at some of the countermeasures. The flight crews must employ countermeasures to ensure that threats, errors, and undesired aircraft states do not lower safety margins. Some of the countermeasures would include comprehensive pre- and post-flight briefings, strict adherence to SOPs, checklists, callouts, and as well as personal strategies and tactics. Now we shall discuss planning countermeasures. Proper briefing and handovers is very essential. Planning and mental simulation. Contingency planning. Execution countermeasures. Monitoring including self-regulation, checklist discipline, cross-check oblique rechecks, that is check, recheck, and double check before operating any critical levers, buttons, and switches. Maintaining situational awareness. It is important for maintaining situational awareness that the information management is good. Task workload management is essential. Pilots must review countermeasures. They should evaluate and modify plans, inquiry and questioning. All countermeasures are necessarily flight crew actions. However, some countermeasures to threats, errors, and undesired aircraft states that flight crews employ build upon hard resources provided by the aviation system. These resources are already in place in the system before flight crews report for duty and are therefore considered as system-based countermeasures. The following are the examples of hard resources that flight crews employ as system-based countermeasures: airborne collision avoidance system, ground proximity warning system, standard operating procedures, checklists, briefings, training. Other countermeasures are more directly related to the human contribution to the safety of flight operations. These are personal strategies and tactics, individual and team countermeasures that typically include canvassed skills, knowledge, and attitudes developed through human performance training and crew resource management training. To conclude, ladies and gentlemen, successful threat and error management will ensure safety of the flight. Consequences of errors that are not corrected or not contained can result in an undesired aircraft state and possible accident. Threat management provides the most proactive option to maintain margins of safety in flight operations by avoiding safety compromising situations at their roots. As threat managers, flight crews are the last line of defense to keep threats from impacting flight operations. Using threat and error management, individuals can plan and apply appropriate countermeasures to identify and then manage threats and errors to prevent them from leading to an undesired aircraft state, compromising the safety margins. Responding quickly and applying the appropriate actions to manage and resolve the threat and error ensures safety. Threat and error management is a continuous process, the practice of ongoing planning, appreciating, and controlling the progress of events to ensure a safe outcome. Flight and ground crews should become better threat and error managers. They should actively identify threats in their operation before they reduce the safety margin. It is important to learn strategies for managing the threats. Look for errors that you have made and correct them. Remember, error management is managing your past. Threat management is managing your future. Operators must continue to build a safety culture by encouraging open and honest communication. Thank you very much, ladies and gentlemen, for taking time out of your busy schedule to watch this video presentation on threat and error management. I am sure that after watching this video presentation, you are well placed to manage threats and errors in a competent and professional manner. Wishing you all happy and safe flying and many happy landings. Jai Hind.